Here we're asked to identify the given conic and then provide some information about that conic. We're given 2x squared plus 3y squared plus 4x minus 6y equals 13. We're going to go ahead and start by rewriting this and complete the square in both x and y. So if we rearrange, group the x terms together and group the y terms together, we can rewrite this as 2 times x squared plus 2x, group that in parentheses, plus 3 times y squared minus 2y is equal to 13. And we can complete the square in x, and we can complete the square in y. So we'll have 2 times x squared plus 2x plus 1. So if we divide 2 by 2 and square it, we'll get 1. Plus 3 times y squared minus 2y plus 1. So we divide negative 2 by 2, we get negative 1, and we square it, we'll get 1. Now, on the right side, we need to add. Since we added 1 in here, 2 times 1 gives us 2. We're going to add 2 on that side as well. We added 1 inside here. 3 times 1 is 3, so we need to add 3 on this side as well. That allows us to write this as 2 times x plus 1 quantity squared plus 3 times y minus 1 quantity squared is equal to 18. We'll write this as 2 times x minus a negative 1 quantity squared plus 3 times y minus 1 quantity squared equals 18. And if we divide both sides by 18, we'll get x minus negative 1 quantity squared over 9 plus y minus 1 quantity squared over 6 is equal to 1. Now in this form, we can see that this is the equation of an ellipse. The ellipse will have a center of negative 1, comma 1. We get that from the x and y parts up here. The major axis is going to be parallel to the x-axis, and we have that a squared is equal to 9, b squared is equal to 6. Using that, we can find out what c is. Since c squared equals a squared minus b squared, we'll get that c is equal to the square root of 3. The foci for our ellipse are going to be at negative 1 plus or minus the square root of 3, comma 1. The vertices of our ellipse are going to be at negative 1 plus or minus 3, comma 1. So this conic is an ellipse. The center is negative 1, comma 1. We have these foci and these vertices.